Hello, my name is Michael Meyer, and I'm a professor of astronomy at the University of Michigan. When I was a young person, I watched a television program called Cosmos by Carl Sagan when I was in the middle school ages from roughly 12 to 14. And this launched me on an exploration to try to find out what I really wanted to do and how I could participate in exploration and space science and astronomy and astrophysics. Brown dwarfs are a very fascinating intermediate space in between stars, which are defined by their ability to fuse hydrogen into helium in their cores and thus drive their luminosity and evolution throughout their lifetimes. And planets, on the other hand, which simply either glow from the energy that they receive from their star or the energy of their own formation, the gravitational potential which is turned into internal energy and then slowly released over time. Brown dwarfs, which probably form very much like stars do, represent a continuum of the star formation process all the way down through the planet process. I personally am not very focused on definitions of astronomical objects as much as understanding their physical properties, how they came to be, and what their future evolution and end states might be. Well, I believe that understanding the composition of planets from their formation is key to understanding whether or not they might eventually harbor life. I believe we have so much still to learn about the processes of planet formation and the wide range of diverse planetary systems that we've discovered out in the Milky Way galaxy so far. And furthermore, that their atmospheres display a dizzying, bewildering array of properties. One can be so diverse from another. What gives rise to all of this diversity? And if we can understand how those atmospheres operate, I think that's the first step to trying to assess whether we could ever detect biosignatures in the atmosphere of a distant planet. Well, the recent times have been extremely exciting. I've been able to use the James Webb Space Telescope to make all kinds of exciting investigations and learn many new things about the processes of star formation and planet formation and exoplanets and their properties. I think towards the next few years, I'm extremely excited about the first light of the extremely large telescope, the 39-meter ELT, being built by the European Southern Observatory, in which we are very fortunate at the University of Michigan to be able to participate. This telescope, from the ground, before future space missions will be able to do it, has the capacity to image small rocky planets around the very nearest stars. And I think once we can get those images of those first planets and start characterizing them, it will open up a whole new realm of understanding planets in the liquid water zone and whether they might or might not be habitable. The ability to combine the sensitivity, the wavelength coverage, and the relatively large field of view of the James Webb Space Telescope with the extremely high spatial resolution and spectral resolution of a 39-meter ground-based telescope, it makes the combination of the two much more than the sum of its parts. Well, beyond the horizon of being able to use the extremely large 39-meter telescope and the James Webb Space Telescope together in the next decade, we can look forward in future decades to incredible facilities like the Habitable Worlds Observatory and potentially characterizing Earth-like planets in the liquid water zone from the reflected light, and then also, hopefully someday, also with missions like the proposed LIFE mission, looking at those same worlds in their thermal emission and really study whether these worlds could have a greenhouse that would help them support life on their surfaces. This, I think, will be the next big exploration in the next 30 plus years. I have been at workshops at ISSI before. One workshop on the formation and evolution of star clusters many years ago, and another workshop inspiring to understand the origin and delivery of water to early planetary systems. The workshops were fantastic opportunities to have international colleagues come together in a quiet and thoughtful space for a concentrated period of time and really have the kinds of scientific discussions we wish we would have in the corridors of our own home institutions. This time as the Johannes Geiss Fellow, it has been extremely wonderful to be in the quiet environment of this place and to have time for thinking and writing, which I normally don't have in the busy day in my institute when there's so many tiny things to do every moment of every day. During my time here in 2024, I was able to work uninterrupted for long periods of time and in fact complete a research paper, or at least submit the research paper tomorrow. I hope that I do. In addition, I've been able to collaborate with colleagues here at the University of Bern, not far from the ISSI Institute, but also colleagues in Zurich and throughout Switzerland in different aspects of exoplanet science, which has been extremely rewarding. Another advantage of being here at ISSI in the year 2024 was additional time to explore Bern. I've been here many, many times, but I have not had the luxury of wandering down into the old city, tasting some of the finest espresso that one can find in Central Europe, and going to see the new enclosure for the bears down in the center of the city. It has been a really wonderful experience and one that I was able to share with my children. Thank you very much, and goodbye.